Hello! In this video I would like to take a look at the Sega Dreamcast Race Controller, paying particular attention to the problem of its dead zone and showing how I fix this with a simple microcontroller circuit. There are a lot of great driving games available for the Sega Dreamcast, and so you might be tempted to pick up a racing wheel to go with them. Sega produced a lot of excellent accessories for their systems, but this wheel has attracted somewhat mixed reviews. I do like the styling of the wheel, and it feels quite nice in the hands. There's no force feedback, but it has a decent resistance and springs back to the centre position quite reassuringly. However, once you start playing a game with it, you'll soon find that it feels quite unresponsive, and this makes accurate steering and small corrections rather difficult. Dare I say it, I found it easier and less frustrating to play the games with the stock controller. What's going wrong then? As alluded to earlier, it's the size of the dead zone. Allow me to demonstrate. The dead zone is a region around the wheel's central position when no input is registered. You need to move the wheel outside this dead zone before it starts reporting that you've moved it. This is to compensate for limitations in the wheel's centering mechanism and position sensing. You don't want the wheel to drift to one side or the other when you're not touching the wheel. A dead zone should be large enough to work around these limitations, but still small enough that you can't notice it when you start intentionally moving the wheel. Unfortunately, as you can see, in the case of the Dreamcast Race Controller, this dead zone is simply much too big, meaning that you have to move the wheel quite a distance before your vehicle starts to respond, making the controller as a whole feel sluggish and unresponsive. Here you can see that as I move the wheel from side to side, the indicator on the screen moves smoothly for a bit, then sticks in the middle for a fairly long time before starting to move again. When it's stuck in the middle, that's an indication that you are trapped in the dead zone. This calibration screen can be used to set the size of the dead zone, but only in addition to the existing dead zone implemented within the wheel hardware itself. There is no way to reduce the size of that hardware dead zone, so this software compensation that can be applied here, you can see I've marked a larger dead zone in the middle. The problem here is I don't want to set a larger dead zone, I want a smaller one, and this calibration screen will not let me do that because the problem is within the wheel itself and not the software. There is a similar issue at the extreme ends of the scale. You can see that once I hit the left edge there, the wheel hasn't gone all the way as far as it can go to the left. There's still quite a bit of extra space, and you can see that as I move the wheel in that area there, nothing is being reported to the console there. We've already maxed out. Similarly, if I go to the right here, there's a region at the top end of the scale where the wheel has already been maxed out. It's not reporting any movement within that area beyond the fact that you've gone as far as you can to the right. And as before, on this calibration screen you can set an upper limit like that as well as a lower limit. So here I've set a larger zone at the end where that region there will be reported as the maximum area. However, this is something we don't want to do. We want to extend the top end of the scale rather than reduce it. So unfortunately, all of these issues that we have with the wheel cannot be fixed within the game software. So that is the problem. What is the fix? Let's take a look inside the wheel to see what can be done. Here is the wheel's position sensing hardware. It's not very high-tech at all, just a 100k potentiometer. This is wired directly across the controller's power supply, so it outputs an analog voltage corresponding to its position down this cable into the controller's PCB, which is down here. The wheel is centred using this piece of bungee cord that's connected from here round through this mechanism down here and back up here. Cheap and not particularly cheerful. I wonder if the use of a bungee cord rather than a spring and a noisy potentiometer instead of, say, an optical encoder led to the decision to use a large dead zone to compensate for the inaccuracies of the cheap hardware. However, this simplicity does at least mean that the wheel is very easy to modify. We can unplug this existing potentiometer and insert our own circuit between this potentiometer and the controller PCB. This circuit can then sample the wheel directly, add a large positive or negative offset to the position to force it outside the dead zone, and then send that new position as an analog voltage to the stock PCB. Here is the circuit that does just that. It has a couple of connectors to allow it to be inserted between the potentiometer and the existing PCB. It uses an 80MHz microcontroller, so it can be easily reprogrammed to get the correction calculations just right. The signal from the potentiometer comes into the microcontroller's analog to digital converter via this connector. Over here, a 1K resistor and 10 microfarad capacitor are used to smooth the 10-bit fast PWM output from the microcontroller into an analog voltage that the controller PCB can handle via this connection. These small clips and screw hole allow the board to be securely attached to the existing PCB. If I flip that over like that, you can see that these two studs pop into there, and there is now a screw hole where the existing screw can go in there. This allows it to be mounted inside the wheel for an invisible, non-destructive and reversible modification. Let me screw this back in and I'll show you. I've screwed everything back together with the exception of the metal base plate, and you can see it all fits quite neatly. If I check the performance of the wheel, you can see that as I move the wheel left and right, it moves through the central position a lot more smoothly than before. There is still a small dead zone, but as mentioned before, this is necessary to compensate for hardware limitations. You may notice that I can also move the wheel closer to the minimum and maximum points before the software reports that I've hit the limit, providing a slightly greater range of motion overall. If you want a larger dead zone or wish to reduce the range of the wheel, this can be now set in the game's software calibration menu as intended. The code that performs these corrections should hopefully be quite easy to understand, so if you do want to replicate this project, it should be simple enough to tweak it for your own needs. Job done? Have a cup of tea to celebrate? Not so fast. Unfortunately, there is at least one game that has a problem with this modification. Here is Tokyo Highway Challenge, also known as Tokyo Extreme Racer. When I first got my wheel, I found that this game seemed to perform much better with it than any of my other driving games, and I think that this game has been specifically designed with the original large dead zone in mind. It's difficult to convey how this performs in-game over a video, but it's very noticeable in the menus, which are now extremely twitchy when using the modified wheel. No matter, surely you can go into the game options and increase the size of the dead zone in software. If I can get through to the key config menu, I would try that. However, and annoyingly enough, Tokyo Highway Challenge does not seem to provide such a set of calibration options, which is why I've provided a way to enable or disable the modification, and therefore change the size of the dead zone in the microcontroller firmware. Hold the wheel all the way to the left when switching the console on to set the small, software-corrected dead zone. Hold the wheel all the way to the right when switching the console on to revert to the default, large, uncorrected dead zone. Here you can see we have set the small dead zone. If I unplug the controller, hold the wheel to the right, and then plug it back in, we are back to the original large dead zone. If you leave the wheel in the central position when switching the console on, it will remember which mode you had it in previously, and it will remain using that, so you don't need to keep holding the wheel one way or the other between play sessions, unless you specifically want to change which mode it's in. You can see we are still on the large dead zone there. Now I want the small dead zone, so once again I'll unplug that, turn the wheel to the left, plug it back in, release the wheel, and now we are back in the small dead zone, and that will be remembered if I unplug it and plug it back in for future play sessions. Now I have the wheel working the way I want it to, I can get back to practicing my driving. I'm still pretty awful at racing games, but at least now I can only blame myself and not unresponsive hardware for my failings. More information can be found in the description box below. And as always, thanks for watching.